Welcome. In this lecture, we're going to go through some kind of more of these useful limit properties. Limits are going to behave generally as well as you could possibly want things to behave. They're going to be things that are true about limits that are not going to be true about derivatives and integrals, and particularly the way they behave with products and quotients. So, enjoy it while it lasts. But, these things are very useful about limits. So let's go ahead and show what they are. And I'm gonna have over on this side I'm gonna go through all of this with an example. For the first two, I'm gonna use the same example. So let's just kind of set up the example. So we're gonna suppose that we have, so we're gonna have three things here. We're gonna have f of x is gonna equal the function x. We're going to have that g of x is going to equal the function e to the x. And finally, we're going to have that a equals 0. Okay, so we're going to suppose these for the first two examples we're going to do. So I'm just going to have these over here, as you can kind of keep them in mind as we go. And looking at these, it's going to be useful to know. So what are the important limits there? Okay. That we know that the limit as x approaches a of f of x, so the x approaches this a, which is the 0 of f of x. What is that in this circumstance? Well, I'm taking the limit as the function x approaches 0, and so that's just going to be 0. Okay, so that's one thing that we know. We also know that, so let's go ahead with the other one. So we're going to take the limit as x approaches x. So as x approaches a of the other function, which is g of x, right, which is e to the x. So what happens is that approaches 0. Well, if you put 0 in, as the exponent on anything, you get out 1. Okay. So this is going to equal 1. Okay, so we're going to use those, but let's just go. So our first rule that we want to go through is the product rule. So what does that say? So this is the product rule. And what does the product rule say? The product rule says that if I take the limit as x approaches a of, and this is going to be the function that's a product of, so we have the function that's a product of f of x and g of x, so we're just multiplying the outputs. When I input x, I multiply the outputs of f and g. Okay, that's actually going to equal the limit as x approaches a of f of x. So we can actually multiply these two limits, which is kind of like the dream come true, that I can just do these limits one at a time and then multiply them, as long as these limits exist. Okay, so the limit as x approaches a, so I'm multiplying these two limits for these two functions. Oops, this should be orange. Okay, so let's show the example over here of this. So this is the example for 4, for the product rule. So over on the example side, I'm going to get that this is saying that if I take the limit as x approaches 0 of x e to the x, right? I'm just plugging in exactly for my f, g, and a over there. So this is x e to the x. Well, if I want to compute this, I could just multiply these two limits. So let's kind of see what I mean by that. So this is going to be the limit as x approaches 0, just of this function x, right? Multiplied by whatever I get there. The limit as x approaches 0 of, and then e to the x is my g, so I just write that. Okay, so I could instead of taking the limit of the product of these two, I could multiply the two limits. Okay, the first one is 0, the second one is 1. I get that from right up there. Okay, so this is equal to 0 times 1, which is equal to 0. Okay, which I got from right there. Okay, it didn't need to be true that these two limits existed. If they don't exist, it gets more complicated. Okay, so that's how the product rule works. You can just actually multiply the limits of the two functions. Okay, quotient rule. So very useful. So here's the quotient rule. Okay, so we're going to have the limit as x approaches a, and now you can guess, this is the quotient rule, so you can guess I'm going to divide the two functions. So I have f of x on top, and then on bottom I have g of x. And then you're going to be able to do exactly what you want to do again. So again, this is going to work out so nicely because I could just take, right, I can take the limits of the top and bottom separately. Okay, and again, I'm drawing these on red so you can see what we're taking the limit towards doesn't change. And we have f of x on top, and we have g of x on bottom. Okay, and then let's go ahead and apply this over in this circumstance. So we are in, this is the fifth rule. Okay, and so I want to take the limit as x approaches. Again, I'm just plugging in those things for my a, f, and g. So I'm going to take on top, I have x, so I take x divided by e to the x. Right, so this is a new function, but it's a function that's a quotient, and so luckily I can use the quotient rule. And we'll go ahead and do that. Okay, and so we're going to get, for this, we're going to get that this is going to equal, right, and we have the limit as x goes to 0 on the top and the bottom. Right, both of these are the limit as x approaches 0. And then I want to take my top function, which is x, so I want to take that limit, and then I want to divide it by, oops, that's a little bit funny how I wrote that. Oops. I forgot my limit sign. So we get the limit as x approaches 0. And we're going to get, it's going to make that a little clearer to see. Okay, and then we're going to get on the bottom function, so we have e to the x. But we know these two limits, so I can take this limit from here. So the top is this limit, which is 0. The bottom is this limit, which is 1. So I'm going to get 0 divided by 1, which is, again, going to be 0. Not every function's limit is 0, but in all these examples, somehow or another, this worked out well. Well, I also chose these examples because I wanted you to get used to these functions.